This next case, you have a semicircular ring of radius r. This is a semicircular ring of radius r. The magnetic field is B into the plane of the screen. You are giving a velocity v in vertically upward direction. Find the induced EMF VA minus VB.
So 2 VBR.
2 BVR. Everyone solve it and give the answer. Be active.
It'll be VBR, right?
No, effectively, if you are connecting this rod A and B, the edges A and B, the length of it will become 2R. So this 2R rod, how is it moving? It's moving with a velocity v in vertically upward direction. So of the rod, what should be the induced EMF? BVL. L over here is 2R. And which will be at higher potential? See the V cross B, you'll get it as leftwards. That means A is at higher potential. So VA minus VB will be 2BVR. If anyone has doubt with this, let me know. Next case. You have the rod like this. Now it's moving to the right with velocity v. Tell me what would be the induced EMF. The same semicircular rod R. It's moving to the right with velocity v.
So this will be VBR.
Think carefully.
So 0.
0. Why? When we connect the rod between A and B, the length 2r will be parallel to velocity. Hence VA minus VB is 0. Is anyone having doubt with this? Okay. Let's move on to next question. So let's say you have this rod, this complete square loop. This is square loop. It's moving to the right with a velocity v. It's moving to the right with a velocity v. Each side has a length L. So this is A, B, C, D. Do it one by one. Calculate VA minus VB, VB minus VC, similarly VC minus VD, VD minus VA.
So VA minus VB and VC minus VD are 0.
Very good. AB and CD, both of them are parallel to the velocities. Their lengths are parallel to the velocities. Hence, the induced EMF is 0 across those two parts.
So
Next.
the first one, VB minus VC will be BVL. Next one will be
VB minus VC will be BVL plus BVL or minus BVL.
plus. The next one will be minus. The D and A.
VD minus VA will be minus BVL. Is anyone having doubt with any of these cases? Okay. Now let's discuss more about this case. So you have this rods. There is some induced EMF across them. That means if you have this rod, it's moving to the right. if it is having an induced EMF of BVL means the equivalent part, remember that you can have a battery of EMF BVL. That's the meaning of the induced EMF. The equivalent part you'll take it as a battery in the place of the rod over there. So coming to this case, so between B and C you can consider it as, I'll redraw the square. So between B and A there is no EMF, so I'll just represent with a wire. Between B and C there will be a cell. You can place a cell which has an EMF of BLV. Then C and D there is no potential difference, so I'll represent it with a wire. Next, between A and D again there is a cell of EMF BLV with higher potential at A, right? So this is how you have the cells. Now see these cells, both of them are in series, just these two cells you have. So you have both of them in series and they are connected in opposite polarities. So what would be the equivalent EMF? It will be 0. BLV and BLV, they are connected in, if you consider it as a series combination, then you will get as 0 equivalent EMF. Though the physical appearance looks like parallel combination, but this is series combination of the cells. This would be parallel combination in case between these terminals if I connect it to some other resistor or some other element, then I can say both the BLVs are in parallel combination. But here clearly understand nothing else is connected, only you have these two cells in this circuit. That means they will be in series combination. So the second part answer, the net induced EMF in this square loop is 0. Across each side we might be having some induced EMF, but across the net across the square loop is 0. Hope everyone is clear with this. Now, let's say you have an infinite long wire carrying current I. This is an infinite long wire carrying current I. Now there is a square loop whose near end is at a distance of D. Rectangular loop, sorry. Okay, just not to confuse, I'll write this as also length L, this also has length L. So this will become square loop. So this square loop is moving with a velocity v to the right. What will be the net induced EMF across this square loop? Just try to solve it the same way that you have solved the previous case and tell me what would be the answer. Just to keep it easy for you, I'm naming the points A, B, C, D. So calculate the induced EMF across A and B, B and C, C and D, similarly D and A.
So could you repeat the case again?
This is infinite long wire. So you have infinite long wire carrying current I. What this infinite long wire will do? It will create magnetic field around it.
Yes.
So due to that inside that magnetic field, you have the square loop ABCD moving. So when you have the square loop moving, you should get the induced EMF. Now 1 minute, I'll go back to this previous case. So the previous case, we have the square loop moving in uniform magnetic field. Over here we got the net induced EMF as 0. The easier method to solve this instead of taking each side is, we have already discussed that when you have uniform magnetic field, you can take the effective length across the rods and then you can find the induced EMF. So over here, since this is a closed part, the effective length will be 0. So that's why the induced EMF is 0. Now the effective length method, you can use it only if the magnetic field is uniform. So moving on to this next question, where we have this infinite long wire, the magnetic field due to this infinite long wire won't be uniform. So you cannot use the effective length method. Without using that, you have to solve this.
So,
Yes.
so will VA minus VB be 0 and VC
Right.
minus VD?
VA minus VB will be 0. VC minus VD will be 0.
So then VB minus VC will be mu naught I 2 pi D.
Okay. So VB minus VC I'll write as BLV, but B is not same everywhere. So near BC wire, let's say the magnetic field is B1. So it will be B1 LV, and what is the direction of the magnetic field? Magnetic field will be definitely inwards. So here let's say it is B1, here let's say it is B2. Now coming to the value of B1, B1 will be mu naught I by 2 pi D. Same way, what would be B2 value? Mu naught I by 2 pi L plus D. Right? Next, coming to VD minus VA. So VD minus VA, A will be at higher potential. So this will be minus B2 LB. Now when we want net induced EMF, what we'll do? We'll add up all of them. Net induced EMF. So this will be B1 LV minus B2 LV. Hope everyone is clear with why we are taking B1 LV minus B2 LV. So this will be B1 minus B2 into LV. So B1 and B2 values we have it here. So this will be mu naught I LV by 2 pi into 1 by D minus 1 by L minus D. So you'll get as L by D into L plus D. Mu naught I L square V by 2 pi D into L plus D. If you have any doubt with this, let me know.